Okay. Um, well, I'm hoping that this live stream works because I have had some pretty terrible live streams so far this week. I tried live streaming on Tuesday and I tried it twice. Both times it failed. So I actually ended up recording an entire video and none of it got uploaded to YouTube. And it was pretty sad because I'll claim it was the best lecture I've ever given. Um, quite frankly, um, I have reached a point where I am tired. These lectures have not been good. They're not the best quality. I feel like I'm fighting technology more than I should. I just want to get you something that is workable. And online education has not been the best for that. This class was never intended to be taught online. Certainly not in the modality that I have been teaching it. So with that said, I'm going to not be giving you any more reading assignments. I am not going to be giving you any more lecture quizzes. I am not going to be giving you any more SolidWorks modeling assignments. You have a final project due and I want you to focus your efforts on that. That is the most important thing that we can get done with the rest of the semester. I don't honestly feel like anything else that we do is going to be as beneficial. If you want to watch through the SolidWorks videos, great. I would applaud that because it's good learning experience. A great way to learn something that I think is necessary to understand 3D modeling. SolidWorks is a foundational software that a lot of 3D modeling softwares are built similar to. I worked in a software called LS-DYNA. They put together a meshing program for interfacing with the coding of their device, their software, and it was built off SolidWorks, built the same way. LS Prepost is, well, the original LS Prepost was not. But I feel like if you understand SolidWorks well, you can understand other types of 3D modeling softwares. And this is 3D modeling softwares that can model fluids, that can model tissues, that can model elastic members, solid members, everything. So even though, yeah, we are learning SolidWorks here, my motivation is not to teach you so that you only ever understand SolidWorks. SolidWorks has a lot of competency and capabilities, and it can do a lot of things. But there's a lot of programs out there that we aren't covering, and that I don't have time to cover, and you don't have time to learn, and you will never use. So we're focusing on SolidWorks because it is something that we can use and we do use in this program. So, beyond that though, I want to make sure that you understand the 3D modeling, 3D device design, mechanical device design, which is the last segment of our course. We've covered the design process. The lecture that I would have given on Tuesday was about product evaluation and how important that is to the overall quality of a product. That's gone. I have no idea where that went. Got lost between my computer and the interwebs. Probably sitting on some server right now, or being smashed with a hammer. Somebody's private email. Never know. Regardless. So what I think I'm going to do for these videos now, going forward, is I'm going to focus on helping you complete your project. Okay? I'll take the very beginning of this lecture to talk about what I'm expecting. You have an assignment due today That assignment is to give me your model. This can be something just like a screenshot. It can be a picture. It can be something. If you're not using SolidWorks, I will be expecting either a 2D AutoCAD layout or a 2D sketch drawing showing me that you have a design for your device. I specifically asked for the structure. If you know what your structure looks like, you know what your design looks like. I've been only drawing in SolidWorks on my structure because I haven't been showing you the fact that I actually do have sketches of what I consider to be my 3D printer, my pancake printer. I'm building this off of that. But in any case, tonight, by midnight, you need to upload a picture of that. It can be an assembly, it can be just the structure, it can be whatever you think shows me that you have made progress. If you don't upload anything, you're obviously not showing me progress. If you upload something and it's a box, and it's something that you could make in 3 seconds in SolidWorks, that's not showing me you've made progress. It shows me that you've opened up the program and you've done something. If you draw something, and you draw something that is just a box, again, I need to see that you've made progress. I need to see that there's an actual design behind what you're trying to do. If your design is very, very simple, then give me a little bit more than just a box. I'm going to need some context too. We talked in our last video last week about the importance of having something that gives you connection spaces and connection points, places to mate to when you build assemblies. You should have thought about how your assemblies connect. That is a piece of it. So, for the rest of this video, I'm going to dive into some SolidWorks. We'll start right back up where I left off last time, where I just had the heating element. I'm going to try to finish up the rest of my assembly today. And then next week, we will be talking about professional displays on Thursday. I will not be having a lecture in this class on Tuesday unless somebody tells me they want to see me do a lecture. I don't see the purpose in throwing lectures out if nobody's going to watch them. If even one person says, I would totally watch more lectures for this class, heck yeah, I'll keep doing this because I love teaching. But I'm not going to have a lecture on Tuesday knowing that there is no requirements for any lecture watch at all. I'm not going to add stress to everyone's lives, including my own, just because I like teaching. I can come up with a YouTube channel and teach if I really want to. I can poorly stream these YouTube videos there. Oh, it's not funny. Yeah. That was a really dark laugh. It's very quiet in this office. It's snowing outside. You don't need to know this. Alright. Okay, so here's my streaming software again. I did a lot of edits to try to fix the audio quality. Once again, I'm gonna have to make sure that this even works. I've actually broken a few things on my computer trying to make the audio work. But I think I've got something now. I think I am there. I had 3 different audio inputs and they were all competing at the same time, and it was causing some very challenging issues. So that's something that I get to I've learned. Okay, so I'm going into pancake printer. I got my assembly, got my hot plate, got my structure. What I'm going to do now is I'm going to put in the extrusion element. Okay. So I'm going to open up my assembly. Yes, I always want to use SolidWorks to open this assembly. Need to make sure that, okay, if you leave a comment, I will try to make sure that I see them. Again, waiting for SolidWorks to pull up, so Feel free to just say hi. I like knowing there are people actually watching this. I'm not just wasting my life. I admit I'm so poor at YouTube, I don't even know how to really see how many views the video has. Yeah. It's like everything I thought was so simple is not simple at all. Also, I had no idea I was so horribly technologically slow. I don't know when I want to fill out a survey. Something else that I've considered moving forward is some of you are behind on assignments. It happens. The online learning has made being behind on assignments very easy. Kind of upsetting, but it happens. Everybody gets behind at times. I would hate for somebody to get sick and be unable to finish the semester because I'm continuing to add more assignments. COVID is not a laughing matter. It's not funny. And I mean, people are really dying about it. The university has taken drastic actions. Everybody's taking drastic actions. And they're necessary. We can't simply say that this will blow away. The economy is hurting, yeah. Everybody's hurting. They're talking about not having football this fall, and that is something that personally hurts me. I know it's silly, but it's something that brings a little bit of positivity. But we're looking at this and saying, well, what's it going to take? It's going to take people like you doing your best to keep up on schoolwork. It's going to take people like me being understanding. So please feel free to email me at any time if you have questions, issues, problems, you get sick, you need help, you need time, let me know. I'll do whatever I can. Okay? Alright, so on a lighter note, here's the structure. It's finally loaded. I am going to be putting the extrusion element up here. And I'm also going to be putting a fourth component, which is going to be the storage element. You know what, I may make my extrusion element be 2. I'll put in what a lot of systems have is they have these bars that go here, and then they have worm gears on a moving bar that allows it to move forward and backward. I'm going to go ahead and just design a brand new part. So I'm going to go into File, New, create a brand new part, and for this part, ooh, I should pop it up so I can see. SolidWorks, don't do this to me. Okay, just gonna shrink it down a little bit. Last week I lost my bar. Yeah, it still doesn't come back. I put it way down there. Oh wait, there it is. I wonder if I can grab it and drag it back up. Probably not. Oh well. He was annoying me anyways. Okay, I should be in part 1. Come on. Come on, SolidWorks. Come on, SolidWorks. There you go. Okay, so brand new component. Getting a phone call. I'll have to call them back later. What we're going to do is we're going to start by creating a sketch. I'm just going to make a round bar. This is going to be very simple. Okay, so I'm going to sketch this on the front plane. It's going to be circle. I'll start the circle at the origin. You'll notice that the orange dot shows that I'm pointing at the origin. Click, drag, up, got a circle. Going to dimension this before I leave. I'll make this 1/4 inch. 0.25. Okay, exit sketch. Now before I really go into anything else, I'm going to pop up my assembly and I'm going to take a quick measurement. Okay, I want this bar to go from back here up to over here. And I would assume then that the motors and the components driving that bar would actually be placed somewhere inside of this box. So I'm going to go to evaluate, I'm going to go to measure. I will click on this edge, which tells me that's 14 inches. And then I will click zoom in, click on this edge, and the distance between them is 16 inches. Okay, so I need to come up with a 16-inch line. So I'll go back into my part 1. I will go into features, extrude, and I'm going to make this be 16 inches long. I'm just going to go ahead and say yes. I want it to be blind, one directional. There we go. Okay, so now I've got this really long bar. I'm just going to save this. It's not uncommon to have very simple parts in SolidWorks. Now I could represent this as a threaded rod. This could be a threaded rod. I don't have to draw it as a threaded rod. I can draw it as a very simplistic model of what I'm trying to do, and then later in the details specify this is a threaded rod, not just a solid cylinder. Okay, so there are some ways of cheating this to make your model easier. You don't have to draw it where you show every single thread on a threaded rod. That's a little overkill. I'm going to go ahead and call this threaded rod and save. Okay, so now I'm going to have 2 of those. Perfect. Awesome. Oh, I lost my face cam. Oh. Dang. Apparently my streaming has decided that it would look better without me in it. Well, drat. Ah, there it is. It's back. Just fickle HDMI connection. Thank you, Grace. So I've got this this threaded rod. That's going to be one of the components I have. Good. The next thing that I need is I'm going to go back to my assembly real quick and take another measurement. Oh, come on. I already saved you. There it is. Okay, measure. And this time it's going to be from here to here. Okay. Length is 16 inches. Distance between them, well, should be right click, clear selections. $14 inches. Okay, so I got 14 inches. We'll probably have it be 12 by 12 inches. Good enough for me. So I will create a brand new part now. Go to open part. Okay. And now on this brand new part, I'm going to make it be, this is going to be the extruder piece. It's going to be a flat piece that travels along the threaded rod. When the threaded rod rotates, it causes this flat piece to move. Okay. So I'm just going to start with a sketch. We'll do it on the top plane. It's going to be a rectangle. I'm going to go here to here. I'm going to make it thin, but I'm going to make it 12, 13 inches wide. So this is 13, enter, forces this to be 13. I want it to be about 13 by 2 inches. Okay, so a little bit skinny. And I'll exit sketch. Okay, since I drew it at the origin and I put the dimensions in, this is fully defined. I'm going to go ahead and extrude this. I don't want it to be very thick, maybe a quarter of an inch. Don't need this measurement anymore. I'll change this dimension to 0.25, and now I have a quarter-inch thick metal plate. This doesn't have any way to connect to those rods though, and that's kind of a problem. So what I'm going to do to kind of make this work is I'm going to create little circular, basically brackets that are going to mount to the thread rods. They're going to have threaded hole cut in it so that the threaded rod screws in, and then when the threaded rod unscrews, it causes it to move up and down. That's how a lot of 3D printers work. Okay. Now I do realize that this only gives me one line of action. I can only print pancakes that go straight forward and backward. But you know what? It would take me a lot longer than this to try to come up with one that gives the forward, backward, up and down. I'm just trying to show you very simply how to build this. So the next thing I need to do is on the bottom of this, I need to mount those brackets that connect to the threaded rod. Okay, so I'm going to go down here and I'm going to say File, Sketch. I just want to keep hitting File for some reason. Pick a sketch plane to sketch on. I'm going to pick the bottom of this face. I'll go ahead and orient my orientation so that it is looking at the bottom here. Actually, I just want to click this and go to normal 2 so that I'm looking at it in this orientation. Now what I'm going to do, instead of creating this perfect little thing, I'm going to go ahead and draw a center line like this, and I'm going to draw a rectangle like this. Okay, now this center line, first of all, I'm going to add some relations to it. I want this to be vertical. Okay, yes, I want that to be vertical. I'm going to hit escape so that I'm not selecting it. I'm going to add relation. I want this point and this edge to be coincident, so they're touching each other. I could have just drawn originally from there to there, but whatever. I'm not creating a brand new relation. I want it to be between this point and this edge. Again, coincident. There we go. Smart dimension. I want this to be located. This is going to be in about ½ an inch from the edge of the bar. Okay, and my rectangle overlaps that, so I should probably dimension my rectangle. Click on this side. I want this side to be shorter than this. You know what? I don't want a dimension there. I'm going to delete that. I'm going to drag this edge over, and I'm going to create a dimension here. Well, you don't need to see me, but thank you for letting me know. Me plus technology. We do not get along. Okay, I don't know what the 0.41 is pointing at, so I'm going to try again. This line to this line. I want the smart dimension here. to here. I don't have any idea what 0.41 is. It's probably, oh, this is the distance from that line, from the center line to the other line, so it'd be like, it's assuming that I'm going to mirror it around the center line. Brilliant. You know what? I'm going to use this. I have a 1/4 inch rod. This distance here needs to be 1/4 of an inch. Okay? Now you'll notice that as soon as I do this, my sketch is fully defined. I only had to put in 2 dimensions. First of all, where the center line of that hole was, and second of all, how far away this is, well, how big the hole is that I'm going to be extruding around to. You'll see what I'm doing in a second, because I'm going to do a revolved extrusion. So I'm going to go here into features, and I'm going to hit revolved boss base. Right now it wants to revolve this 360 degrees. It is already selected my center line. SolidWorks knows I'm going to revolve around the center line. That's why I drew the center line. But I don't want it to go 360 degrees. I want it to go 180 degrees. Okay? And look, it's going the wrong direction now. Let's flip that. Ah, no, that changed. Ah, it changed the angle, not the direction. Go ahead and flip that. Okay, so, ooh, gross. Gonna need to. Eee. Oh, that. That didn't quite work the way I wanted to, because it ended up with a half circle. Oh well, we can always cut that out later. I'm gonna go ahead and set yes. So now I've got a half circle hole here. Doesn't do me a ton of good, but that is an incident that shows how to use revolution. But now I have to do a new sketch and get a hole in here and finish the rest of the circle. Okay, I'm gonna add relation, gonna make this arc and this arc be, I think I can say equal. And then hit enter, escape, and now it's fully defined. Okay, so a couple of relations. I don't even need to dimension this circle at all. I'm going to go ahead and exit sketch, and then I'm going to cut all the way through. So I'll go into features, extruded cut, make this cut, go through everything. Okay. And now you can see if you orient it correctly, you can actually see there's a hole there. If you don't orient it correctly, it just looks like a circle. Okay, great. I need to mirror these 2 features to the other side. So I'm going to start by mirroring this one. I'm going to create mirror, and it is a feature that I want to mirror. The plane that I'm going to mirror around, there is no plane right here. I could create a plane just to mirror around this. I'll show you how to do that, because I think that's an important thing to understand. So if I go into, let's see, I know you can do it through insert reference geometry plane. That's the way I'm used to doing it. It's going to ask you for several references. Now this is where things get a little ridiculous, but whatever. First reference, I would like my first reference to be this right plane. Okay. The plane that I'm going to mirror around is going to be parallel to it. I'm going to have it go the opposite direction. It's going to go in this way. Ah! Nope, I can't. Apparently, if you make it parallel to a plane, we'll make the offset distance be, I want it to be half this distance. Okay, so that's 6.5. Okay, and that puts it right in the center there, and we're good to go. I believe Nope. There's a way to set it so that this plane is created right smack dab in the center of that piece, but I don't remember how to do that right now. This way I'll do it. So I've just created a plane, and now I'm going to mirror these features across that plane. So I'll go back into my mirror command. I am going to be mirroring revolve 1. The plane that I'm going to use to mirror around is that. It'll show up in yellow here. Give me that mirror. Yay, so there we go. Now I'm going to also mirror the cut. Okay, so the cut's already selected because I just selected it. Mirror the plane, you can see that the circle shows up. We're good. Okay, so here is my piece. This is going to ride on top of the threaded rods moving forward and backward in the machine. I'll show you when I finish the assembly in a bit. Okay. Also, I keep acting like my face camera is on, and it clearly is not. So, awesome. All right, the next thing that I'm going to be building is I'm actually going to be constructing the container that's going to house all of the pancake batter. Okay, the extruder bin and nozzle. So my extruder bin, it's going to be a brand new piece, so I'll go ahead and save this. I'm going to call this Carriage, because it's a carriage that rides on the threaded rods. I'm going to create a brand new part, and this new part is going to be my extruder nozzle. Okay. You also notice that on the last part I didn't create any connections for the extruder bin. I should have done that. I can always go back and edit that later. That's fine. So for this one, for my extruder bin, I kind of want it to just be like a bowl. It has a hole in the bottom of it. Because the bowl makes it really easy. You could, like, you close off the bottom of the bowl with like a motor or something, and then you mix it up in the bowl, mix the batter all together, and then it will open up that spout at the bottom as needed. So it'll be kind of like a bowl with a tube coming out of the bottom of it. And I'll make a bowl and the tube two separate parts just because I can. So this will just be the bowl part. Start with a sketch. When I hit sketch, nothing shows up. So I'm going to go ahead and click front plane, sketch. Now I'm going to create a bowl. For this, I'm going to want a center point arc. Make the right here, the first point is the center point, second point is the first point of the arc, third point is the second point of the arc. So I'll click here, I'll go then like this. Okay, hit yes. Now to make this a perfect half circle, I'm going to go into add relations, select every one of these points, and I'm going to make them horizontal. Okay, so that's a perfect half bowl. I'm going to want the bottom of this to be flat. It'll make it a lot easier for me to cut this. So I will go ahead and draw a line like this. And then I'm going to make this point, add relation, that point shows up. I'm going to connect it to the arc. I'll make them coincident so that they touch each other. Add relation, that point and this arc, also make them coincident. Okay, this is already horizontal, so that shows up. Hit yes. Now this point is not defined, this circle is not defined, the radius on the circle isn't defined, the distance on this from the center isn't defined. So I'm not fully finished with this yet. But before I do, I'm going to go ahead and trim, and if you click and drag on the bottom of the circle, notice you get a gray line when you click and drag. That's how I cut out the bottom of the circle. So I'll go ahead and say, yes, I like that. Okay, now for my last dimensions, I need to know what the diameter of this circle is. So my bowl diameter, I'm probably going to want to be, you know what, I'm going to be, it'll be a 6-inch bowl. It's not massive. And then as far as depth goes, if I make it, I cannot make it 6 inches deep. That will not work. It is 6 inches in diameter, which means there's 3 inches between here and the bottom of this. So maybe 6 inches. Maybe this isn't the best design. Okay. I'm going to go ahead and say this right here is, nope, I don't want to dimension that. And delete this. Since I'm going to be connecting this to a tube, I'm making the bottom part flat so that I can mount a tube to it. I'm going to dimension this. I'm going to say I'll probably have a 1-inch tube. Okay, so I'll make the flat part 1 inch. Awesome. And then I'm going to extend these sides up a little bit so that I have a little bit more volume to my bowl. So I will make you go up. And then I will make you go up. And then I'm going to add a relation between this point right here, which is the end of the line, and this point right here. And they're going to be horizontal. So this entire thing is symmetric. I'll go ahead and dimension this line. We'll say that this is just 2 inches. Okay, so I'll have a little bit of space to dump some pancake batter in there, maybe mix it around before it goes through the tube. Okay, now this says it's fully defined, but I'm not quite done. I want this to be hollow. If I were to revolve this right now, put a top on it, revolve it, it would not be hollow. I could make a thin feature, which probably would be my best bet. I'll just do that. The exit sketch. I'm going to go into features, revolve boss base, and then this is going to be a thin feature. I don't want it to be 0.1 inches. I am going to want this to be maybe metal, 0.125. Hey, no. 0.125. I don't know what I was trying to do there. It's asking me for an axis of revolution. I didn't really create an axis of revolution. I'm going to go back and do that real quick. So I'll go and right click on sketch, edit sketch. I'm going to create a center line. I'm going to go from midpoint here to the origin. Okay. Now that's fully defined because this point is defined and that point is defined. So I'll exit sketch, go back to my features, go back to my revolve base, select this line. I do not want it to be closed. I do want it to be a thin feature. Here, I want it to be revolved around here. I want it to be thin. Oh, it has a problem because it can't go 180 degrees without intersecting itself. Okay, I'm going to try going back into the sketch. Edit sketch. Go ahead and trim this off. We're good there. Delete this. Delete this. I lost a lot of my dimensions and everything. This is 1/2 inch, which is what I want it to be. I'll leave it that way. Radius here is 3 inches. It's also what I want it to be. Now everything again is perfectly defined. I'll exit sketch. Try revolving it again. It's going to assume that I want a closed feature, and you'll notice that now the thin feature is working. I only had to draw one side of it. Okay, so that'll be my bowl. I mean, 1/8 of an inch thick, revolved 360 degrees. I'll go ahead and say yes. So there's my extrusion bowl. Awesome. And now I'm going to punch a hole for a 1/2 inch tube to go out the bottom of it. So create a brand new sketch. Going to go zoom in. You can't draw a sketch on a round surface. That's why I made the bottom of this flat. Okay, you could have made a different plane and then extruded a hole all the way through the bottom, but you know what? I wanted this to be flat because what's life without whimsy? Go ahead and create a circle. Now this has projected the origin onto this plane, so I can use the origin as a point. All I have to do is I'll put the center in the origin, which is the center of the circle, and then I will make this be 0.5 inches in diameter. Exit sketch. Okay, I'll go back into features. I'm going to cut this hole out. Instead of being blind, it's going to go through all. Yes. So now I have a bowl with a hole in it. Go ahead and save this. This will be my batter storage. I got one more part I got to create, and this one is the tube. Okay, so new part. Okay, and usually tubes they may be ridged. They may have some features on there that allow for materials to pass through better. I'm just going to make it look like a tube. So again, sometimes drawing it simply doesn't hurt you if it makes sense. Go ahead and sketching a top plane, drawing a circle here, draw a second circle here. Both of them at the origin. Go ahead and smart dimension the first diameter. I want this to be, oh wait, no, dang. Excuse me. I want the outer diameter to be 0.5 inches. Whoa, okay, not 0.05. 0.5, and then I want the distance between this circle and this circle. It's a radial distance because they both share the same center point. I want the tube diameter I want the tube thickness to be 0.1 inches. Okay. I'll go ahead and exit sketch. It's fully defined there. Features, extruded boss base. It knows right now that that's what I want. Then I'll give it, let's see, let me go to my assembly real quick. Gotta take a measurement. Come on, assembly. You know what? I'm just gonna make this 6 inches. Assembly isn't loading right now. SolidWorks is probably hating how many things I'm doing right now on my computer. So I'll just go ahead and say yes. Now this represents a 0.1 inch thick walled tube that is 6 inches long. It can be whatever material. I can always state whatever material. If it's ribbed, if it's not ribbed, if it's smooth, if it's solid metal. I can always state that later. Now this is going to be my extrusion quote-unquote nozzle. It's going to be gravity fed, which means that it's got no more control to it than just unplugging something and letting it fall out. Not quite the pneumatic control that the other system had, but I'm trying to do something simple. Okay, so I got this tube made. I'm going to go ahead and file save it, and I'm going to call this Extruder Nozzle. And now, there's my assembly. I need to know what the distance is from this to the top of that plate, so that as my extruder nozzle's moving around, it doesn't run into the plate. So I'm going to check that vertical distance real quick. I click on this line. I click on this line. It gives me a length of 12.5. Come on, I want to know. I don't know my point-to-point distance is. From here. Sure, here. Why aren't you? Why aren't you giving me a length? Come on, SolidWorks. There it is. And the distance in the y direction is 5 inches. So really I only have about 5 inches for my extruder nozzle. That's unfortunate. I go back into my extruder nozzle. The nice thing about SolidWorks is I can fix it. I'm gonna right click on this, go into edit feature. I had stated that this is 6 inches. I'm going to change it to 4.5. We have a ½ an inch distance between the end of the nozzle and the top of that plate. Go ahead and hit yes, file, save. Now what I'm going to do here is I'm going to create an assembly out of my threaded rods and my extruder plate and my extrusion piece and the nozzle. Okay, I'm going to create a separate assembly out of that. You can make as many assemblies inside of your assemblies as you want. But I'm just going to go ahead and make this an assembly. You could assemble it all into one assembly, that's fine. I'm just showing you that this is possible. Now I've got all of these 4 pieces that I created. I'm going to make my carriage be the important piece. When I put this down, this is the one that matters the most. What I'm going to do then is I'm going to add more parts in. So I'm going to go to Assembly, Insert Components. I'm going to add my threaded rod. Okay, insert components. I want a second threaded rod. Now I'm going to go to View, Hide Show, my temporary axes. Okay, now you can see now I have an axis inside of this and inside of this that I can mate together. So I'm going to go to Mate, zoom in on this line. Notice it shows up as an axis. Zoom in on this line, also shows up as an axis. It defaults to coincident. I say yes. Huzzah. Okay, I'm going to do the same thing over here. I want this axis and I want this axis. Defaults to coincident. I say yes. So now I have the ability to grab onto this threaded rod, pull it in, push it out, move it as I wish. Okay, that's great, but now my 2 threaded rods are at different positions. I'm going to go ahead and fix the ends of these threaded rods so they're at the same position, so it'll be like the this piece is moving relative to these. So I'll go ahead and add a mate. Instead of clicking on the axis, I'm going to click on this end face. Okay, it shows up as a face over here in my mate selections. Zoom out, zoom into the other one, face. And then I'm going to make them be coincident. Okay, if I make them parallel, it won't change anything. The constraints that are already on there force those 2 faces to be parallel because the axes have to be in line. So it's not doing me any good to try to make them parallel. I'm just going to make them coincident. What coincident means is that the planes that those faces lie in are on top of each other. So I'll hit yes, get out of the mate, and now you'll notice if I zoom in here and I grab onto this component and drag it out, they both move together. This would be like how the actual component is, where as the threaded rod spins, the threaded rod moves, causes it to move up the threaded rod, causes it to move down, that kind of a way. Okay, that's how a 3D printer works. Okay, that's great. Now I need to mount on my hose, my extruder nozzle, and my batter containment device. I don't have anywhere to mount that to. I need a hole right here. And I made my hose be 1/2 inch, so I'm going to create a 1/2 inch hole right there. So I'll go right into my carriage drawing. This was my carriage drawing from earlier. I kept it open. And what I'm going to do here is I'll go ahead and do a sketch on this surface right here. Great. Okay. Now what I want to do is I would like to create a line. Goes from this top surf line to this bottom line here. Enter. Enter. Now I'm going to add a relation. I would like the center line of this line. Oh, you know what? I'm going to make this plane and this line be collinear. Okay, so the plane that we created, I can also hide this plane. If I go into view, I can go into hide planes, and I can go hide that plane if I really want to, if it's causing me problems. I actually like having this plane there because I forced that line to be in the plane. Now I don't need to put any dimensions there. Great. Now what am I doing with this line? You know, that's a good question. I don't know why I created the line right there. I'm going to go ahead and say this is for this is a center line. Oh, escape. No, I'm going to select this line and I'm going to say it's for construction. Okay. This means that the whole reason why I drew that line was so that I could draw something else from it. I'm going to create a circle, and we'll create a circle in the center line of the line I just created. And I'm going to make this circle be 1/2 inch. Okay, so I put a dimension on it, it's 1/2 inch. You'll notice when I hit escape a bunch, this circle is fully defined. I hit exit sketch. I go into features, extruded cut. I'm going to have this cut through all. I'll say yes. So there it is. That's going to be my mounting hole. I'm basically going to slide my hose through that hole and then have the bowl just sit on top of this. I could create maybe a bolted plate that goes on the bottom of my bowl that bolts into the top of this carriage. That works fine too. I'm going to make this simple so that it's easier to clean. So now that I've made this adjustment, I'm going to go ahead and hit File, Save. And now I'm going to go back into my assembly. You'll notice this component is part of it. This component is changed. The model, SolidWorks knows that I changed it because it's all one program, and it says, hey, you want to rebuild? And you can already see I've got the hole there. If I don't say anything, it rebuilds anyways. It's already rebuilt. You should say yes. Sometimes rebuilding causes problems if you have mates that are broken. But now you can see I've got my hole there. I can start connecting my other pieces into this carriage. So I'll go ahead and hit Insert Components. I'm going to add the hose. I'm going to add the batter storage device here. And I'm going to go ahead and add the extruder nozzle hose there too. Okay, there's all my pieces. Now I still have temporary axis viewed on these, so I can select this and select this. I'm going to go ahead and mate those two holes together. Shows up as an axis, shows up as an axis. Make those be in line. And then I want the top of this hose to sit in flush with this inner ring right here. Okay, maybe there's a clamping ring or something that goes on there. I could model the clamping ring. I'm not going to because I'm a terrible SolidWorks designer. I'm trying to keep this to be a short video. So I will go ahead and create a mate from this top face here, shows up as a face, to this flat face down here, and I want them to stay put. Okay, now you'll notice that this has an extrusion on it. I would assume there's some kind of a motor there that cuts off and allows flow of pancake batter. I'm not going to model that. I don't need to model that. This is a freshman level class. If I was doing this for a professional design, trying to actually build this, heck yes, I would make that, because you have to draw every single piece. But for this class, I'm not making you design every single piece, because that's a lot of work, and for people who are doing this by hand, it's really hard to model that. Okay, so the next mate that I want to make is I want to mate the axis of that tube with the axis of this hole. Okay, that makes them sit inside of each other. Now, if I click on this and move it, you'll notice that the bowl moves with this hose because I fixed those two surfaces up here, but I'm still able to move this up and down. I'm able to slide it in and out. I would assume that whoever's going to be cleaning this will probably be sliding that out, cleaning it, putting it back in. For the time being, I'm going to go ahead and take this flat surface down here, and I'm going to mate it to the top of this surface. I'm going to make them coincident. Okay, now what that does is it makes it so I cannot move this. It is fully defined. Okay, now I can spin this around as much as I want. You'll notice it says underdefined down here. It's because I can still spin my circular components. That doesn't cause any problems. My circular components are perfectly circular. So the fact that this assembly says that they're underdefined is okay. I have everything that I want out of here personally. This is the assembly that I want. So I'm going to go ahead and call this assembly the extrusion assembly. I'll go ahead and save this. Rebuild and save the document. It's okay to rebuild because all my parts are fine. And I'm going to save this as the extrusion assembly. Okay, awesome. Now that I've built my extrusion assembly, I have all my components fixed the way I want to, I'm going to go back into my original assembly, and I'm just going to add it right here. So I'm going to go into Insert Components. You'll notice I can actually insert that assembly. You can insert an assembly in an assembly that goes into an assembly that goes into an assembly, assuming your computer is powerful enough to handle that. It's sometimes a good idea to build sub-assemblies. That's what this is. This is a sub-assembly. When I go in to put it in, it's not perfect. It's not exactly where I want it to be, and that's fine. I'm going to add two mates that I think are going to fix it. What I should probably do is go ahead and drill some holes in here and then stick these threaded rod through those holes. That's one way of doing it. I'm just going to use other types of mates to force it to fit. Again, I'm not the world's greatest SolidWorks modeler, so I apologize to everyone who taught me how to use SolidWorks. I bring shame on their families. So I'm going to fix the circular edge face of this bar to the flat face of this bar so that it's running in this direction. Okay, awesome. We're in a good place. But I'm not quite. I don't have this oriented the way that I want it to be. I want it to be centered in here, and it's really not centered. Now I do have. If I go into View, Hide Show, I do not have planes on right now. I can turn on that plane. I only created one plane, and it's this one. How do I put this item so that it's in the center of this mechanism? Well, what I'm going to do is I'm going to go back and I'm actually going to edit this device. If you cut in holes right here for the two threaded rods, you don't have to worry about it, because then you just align the holes for the threaded rods and you're good. What I'm going to do instead, since I'm not cutting those holes, I'm actually going to create a second plane in this part, and I'm going to mate that plane to the plane that I have already existing inside of my carriage assembly. Okay, so Gonna go ahead and exit out of the mate, open up, go into my structure, and I'm gonna add a plane that just goes right in the middle. Okay, so we will file, insert, reference geometry, plane. Okay, I want this to be parallel to this plane. Second reference, I want it to be intersecting the midpoint there. So, first place is it's parallel to face 1. Second thing is it intersects that plane. And you'll notice to get this message up here that says fully defined. I can hit yes, and I've created a plane that is in the exact center of that device. Now earlier I showed you how to do it with defining a separation distance. That's how you get it in the exact center. So now I've got this plane that's in the exact center. I will go ahead and save this real quick. It's always a good idea to save before leaving. Go back into my assembly where it's going to say, hey, these things have updated. Say yes, rebuild. Now you can see this plane shows up. I'm going to go ahead and mate these two planes. Both of them are called plane 1 because that's how they were defined in their drawings. Again, an assembly does not contain the drawing, it only shows how to orient the drawings. Mostly what an assembly is it contains the mates of how the parts come together. It's basically a very, very small file that only issues a list of commands on how to mate these components together. So an assembly itself, while yes, it does show this entire structure that we just built, and yeah, I can grab this and move it up and down, which I don't want to do. Yeah, I can. Oh yeah, I gotta put one more mate in. I'm gonna mate the top surface of this plate, do the top surface of this, so that they're coincident. Yes, and then I'll be done. Okay. Now you'll notice because this element right here is fixed in its own assembly, I can't actually move this. That's one of the issues that comes with sub-assemblies, is that the first component you put in an assembly is fixed. I told you earlier not to fix stuff. Well, it's because you can't move it. And it also creates unnecessary constraints. Here I can't drag this, even though technically I should be able to. I'm going to go ahead and fix that. I'm going to go back to the extrusion assembly, and I'm going to click on the carriage, which you'll notice it's got an F right next to it. It says fixed. If I go back into the original assembly, you'll notice right here it's got an F next to it, meaning it's fixed. Where is the... I don't want this to be fixed. Yeah, I'm going to just go back into the original assembly, and I'm going to say I do not want this to be fixed. So, no, I don't want a temporary fix. How do I make that unfixed? Well, there's got to be some way. Oh, it says float. You'll notice the F gets removed. I'm going to go ahead and save this again real quick. Go back in here. I think I can even force this to float here. I should be able to. Should say fix now, but no, it doesn't. Huh. I learned something. I thought you could do that here. Yeah. Okay, well, never mind. Now that I have unfixed it, now that that F doesn't show up on this component here, I do still have the F on the structure, which means I can't grab this and drag it. It will give me the error message that it's fixed. But I can, I should be able to, I should be able to drag this. I'm not. Dang it. Never mind. I should be able to drag it. Apparently it doesn't like it. I should have made one of these threaded rods fixed. That's what I should have done. SolidWorks is going to cause me problems. Because technically these are defined in relation to threaded rods, so I'd have to move the threaded rods in order to move this, but I can't. So yeah, I built this a little backwards. But oh well. If you build it right, you can actually move this in and out, and it'll show you how it slides in and out. That's my assembly. This is good enough for a pancake printer assembly. If you want to have 2 dimensions, go for it. I don't. In my paper write-up, I would say that this doesn't have 2 dimensions. The end. Very simple, very cheap. Only has 1 motor. You'd only have to power one of the threaded rods. Cool. So again, unless I get a comment otherwise, somebody sends me an email, I am not going to be doing a lecture on Tuesday. I believe next week, if I go into your Blackboard program, that's not it, project information, go into your pancake printer, due today is the structure design, due next week is the outline of your proposal, and basically you're just, how is your proposal going to look? So you need to look through how this is graded, what I'm expecting out of here, go back and look through the original document, come up with an outline. I am going to be grading this based on completion. Did you hand me in something that looks like an outline? Okay, if you did, then you get 100%. If it kind of looks like an outline, but it's really poorly done, you'll get half grade. If it doesn't look like an outline at all, you wouldn't like it anything. Okay, so that's how I'm grading that. But do note that is next week. We will meet next week to continue talking on SolidWorks. I'm going to show you how to make professional designs, which that is going to be required for your drawing. Right. Have a good weekend and enjoy not having, make sure to hand in your structure and enjoy only having this project due for the rest of this class.